Hi, this is Ms. Nickel, and this is a video that goes along with the Unit 3 Quiz 3 bonding practice test. And so we've just started learning about electronegativity and polar and nonpolar molecules. So electronegativity is how much an atom wants to pull electrons away from other atoms. So here up in the right-hand corner of the periodic table, we have fluorine, which has an electronegativity of 4, which means that it really pulls electrons strongly. And down here in the bottom left-hand corner, we have some atoms that have the lowest electronegativity values, so they hold on to the electrons the least, and that would be cesium and francium down here, and we have a whole range of values in between. But basically, anytime we have different atoms in a molecule, there's going to be differences in electronegativity, and whether or not the molecule is polar is going to depend on the shape of the molecule. So if we have a polar molecule, then there will be an unequal distribution of charge, meaning that one end will be positive and the other negative. Think of the North and the South Pole on the Earth, right? They are different. And so the Earth is polar, and a molecule that has two different ends is also going to be polar. Okay, so we're going to start out and we're just going to look at shape. Things that are different on the two sides, meaning they're asymmetrical. You can divide them so that the two sides are different. Those molecules will be polar. That's what we're going with. Just like if you cut the Earth in half, you would have a North and South Pole, and they are different. That's what we're looking for. Okay, so our first molecule is bromine fluoride. And so if we were to take a cleaver and chop that one down the middle, we would find that the two sides are different, right? Because one side is bromine and the other side is fluorine. Very different. And so we're going to say this is a polar molecule. Oh, and by the way, its shape was linear. Anytime you have just two atoms, you're going to have a linear shape. You can't have any other shape, okay? So we have a linear molecule that is polar. Next one. And this seems harder than it is. You're going to see it's pretty straightforward. So difluoromethane. We have a central carbon. We already decided anytime we have one carbon, we're going to draw that plus sign, and put our 4 single bonding atoms around it. We get a structure like this. It's like a plus sign. Anytime you see that plus sign, the shape is something called a tetrahedron. Okay? And I think I'll pause the video and see if I could show you guys a shape of, or a picture of a tetrahedron. Nope, I can't do that. Okay, so we'll include that in the next video. Okay, so tetrahedron is what we're going to write down. And I kind of didn't leave enough room for that. I should have written it here. And so, can I divide this molecule in a way that the two halves are different? Yes, I can. These two halves are different, right? And so I am going to call this molecule polar. Just like the Earth has poles, this molecule has poles. All right, next one we're looking at, nitrogen trichloride. So my first question is, what shape is this molecule? So anytime we have a molecule with a lone pair on top and 3 groups, it's going to be a shape called a pyramid. Okay, 4 groups was a tetrahedron. 3 groups is a pyramid. Okay, so I have a pyramid. It's kind of like a tripod. And so you're thinking, if I divide it this way, the two halves are the same. But we're going to look at the nitrogen here as our axis, because this lone pair group up here actually gets to have space too. We kind of think of it as a 4th group. And that being the case, if we divide this molecule this way, then the two halves are different, and we would call this polar. So our pyramidal molecules are always going to be polar. Pyramid is polar. Whether a linear is polar will depend on whether the two halves are the same, and whether a tetrahedron is polar will depend on whether the two halves are the same. But a pyramid will always be polar. Okay, so we're looking here at sulfur dihydrogen. And again, if we draw a dotted line like this, oh, this one's bent. Yeah, I didn't say that. It's the same situation as the pyramid, though. Our bent molecules are always going to be polar. So I'm going to circle polar on that and talk a little bit more about the shape. So how did I know this was bent? Anytime I have a central atom with 2 lone pairs, that forms two bonds, it will be bent because these lone pairs are like rabbit ears. They're taking up space up here. So it's as if you had this plus sign structure, like 4 groups going out, but 2 of those groups are ghosts. And so we get this bent shape, which is just sort of like a piece out of this tripod, and it is asymmetrical. Because it's asymmetrical, it is going to be polar. So I'm going to call this shape bent. And there we go. We're moving on to the next one, moving right along. So 2 identical atoms. 2 atoms will always be linear, and when they are identical, they will also be nonpolar. So this is our first nonpolar atom. You can't have any differences in the poles if they are the same. So we have a nonpolar atom here. Okay, next one we're looking at is hydrogen cyanide, the poison. And so we figured this structure out earlier. It has this triple bond in it. And if you did the molecule building lab, you'll remember this makes a very straight structure because we have no lone pairs here in our central atom, and this triple bond is very inflexible. So this is sort of like a laser gun or a rocket or something like that is what it looked like when we built it. But we have to decide now whether it's polar or nonpolar. And it's very clear that this molecule could be divided in such a way that the 2 halves would be unequal. Is that right? So we are going to call this one polar. I'm circling polar in this case. All right, we're coming to selenium. Selenium is one of those atoms like sulfur and oxygen that makes 2 bonds and has 2 lone pairs. We draw those like this, bent, because those lone pairs are sort of like ghost groups, if you'll remember, right? These are our ghost groups, and they are going to affect the shape. And so because of that, we have the bent molecule, which is asymmetrical. We're going to have a way to cut it in half where the 2 sides are different. And so our shape is bent, and this is a polar molecule. Next one here, methane. So we have a central carbon with 4 groups around it. That makes the plus sign. That is always going to be a tetrahedron. You see that up here. So I'm going to write shape as tetrahedron. And I have to decide if it's polar or nonpolar. Now this one, no matter how I slice it, right? This way, this way, this way, or this way, everything is the same. So this one, even though it looks like a similar structure compared to this one, because I have all the same groups surrounding that central atom, there's no way that any side of the molecule can be different from any other. And so we will call this a nonpolar molecule. Okay? All right, so that is pretty much all the situations you guys are going to see for now. I'm going to post the rest of the key online, but this is the end of the video. Thanks for tuning in, and I'll see you in class.